Welcome to the Continuous Chemical Reactor workshop. In this workshop, we'll have an opportunity to examine typical controls that are applied to such a reactor and to look at how cascade and ratio control are used to achieve operating targets. In the first step of the workshop, we'll change the throughput and examine the behavior of the controls under this condition. In the second part of the exercise, we'll change the target composition to see its impact upon the control. For this workshop, we have a complete dynamic simulation of a continuous reactor. The feed A to the reactor is the primary feed and is under flow control. A second feed B is ratioed to the feed A through a ratio controller. The pressure is maintained in the column in the reactor by a vent system, and the temperature of the reactor is maintained through a cascade control strategy based upon the outlet temperature. Maintain the reactor temperature. The level is maintained through adjustment of the pump out. The composition of the product is maintained through adjustment of the ratio of the two feed streams. In our workspace, we notice that the flow A is shown at the top, the primary flow that determines the feed rate to our reactor. Based upon that flow, that is an input to ratio control that then sets the target for feed rate B to the unit. The composition of the product is measured and is used to adjust this ratio. In the temperature control, we notice it's a cascade of the reactor temperature to the outlet temperature, and the level control is maintained through single loop as well as the pressure through a single loop. In the first part of this exercise, then, we will be changing the target for the flow A, the primary flow, to the unit, and we'll be changing that by step and then examining the behavior of the rest of the control in the process in response to that set point change. So as we can see, we start to respond fairly quickly in terms of the flow, changing the valve. The flow rate is the input to ratio control, so as a consequence, the flow B is also, feed B is also changed to maintain the relationship established by the ratio target. The composition under this condition doesn't change very much, so we'll look at that by examining our chart. So since the proportion of A and B flows is maintained through a ratio control, you notice we have almost no change in our composition, and so we're able to maintain very tight composition control in spite of the fact that the throughput of the unit has changed significantly under this condition. As a consequence, then, we have a stable composition through the use of the ratio control. The temperature control is also fairly effective, as we can see here. In the second part of our exercise, we're going to change the target composition, so we'll change that again by a step to examine the impact of a change in the target composition on the relationship that's maintained between feed A and feed B. We'll see that the feed B is then adjusted to achieve our target through the adjustment of the ratio control set point. The impact of this change is best seen by looking at our chart. Here we see that the flow B, as a result of our change in the concentration set point, the feed B is greatly reduced, which allows then the concentration of the product to be reduced. So we see that through this adjustment, then the composition comes fairly quickly down to our target. We hope this exercise has been helpful to you in understanding chemical reactor control, and we would encourage you to use this exercise to further explore the controls that are provided here, and to use this to improve your understanding of ratio control and cascade control on a unit such as a chemical reactor.